Okay, I want to go ahead and get things kicked off because I know it's a holiday weekend coming up. There's a lot of people that are already out on holiday, but want to get things started. Couple housekeeping related notes. I know we've got a few topics that are still pending out there. We've got a storage backend discussion, which I know we want to get to at some point. So we'll work on figuring out when to plan that. And then there was also talk about how we want to layer the OPI API type functionality and what the layers would look like in some of the different solutions. So this would be something that is around a different set of, various sets of use cases. I know that Venkat was going to be working on something around that, but I know right now he's had some travel issues, so I don't think he'll be joining you today. So with that, I want to get things going again with our Kubernetes infrastructure discussion that we've been having. I know we're digging deeper into it, but let's continue the discussion. So Marianne, I think you still had some additional information that you wanted to go through. I think you're still on mute, Marianne.
Sorry.
There you go.
Thanks. Sorry, folks. So last week we went through the sequence diagram for, the view from the host provisioning side of VF that has a DPU. Sorry, from a host that has a DPU attached to it. So the outcome of that session resulted in a few redraws and a few new sequence diagrams that I was working through over the last week. One question that arose during the last session was around allowing the CNI to do IPAM on the host side. So essentially, in the original sequence, the IPAM was being managed by the DPU. It was returned as part of this NetDev CRD all the way up to the host side. And then, when the CNI ran to move the VF from the host namespace to the pod namespace, it simply queried the host XPU agent for the IP address, and it got it, and then it went off and did whatever it needed to do for that interface for that pod. Obviously, other information may be contained as part of that CRD. For now, I'm just focusing on IP address, but there could be other information like gateway information, routes, and so on and so forth. So in order to show you the sequence of what happens when the CNI on the host side is responsible for IPAM, I drew out another sequence diagram, which is this, which if I actually exit here a second, I'll be able to zoom in a bit better. So when the kubelet requests from the CNI to add VF from the host namespace to the pod namespace, let's assume IPAM happens on the host side. The next thing that he'll have to do is update the NetDev CRD with the IP address in order to send it all the way back down to the DPU to tell it what IP address we've decided to allocate on the host side. So this kicks off a series of, calls to essentially update a CRD, which gets pushed to the tenants control plane, which then gets pushed to the DPU or the infrastructure cluster control plane, and eventually through the operator gets synced to what is the XPU agent. And here, I guess I call this number, call it number 34, allocate the NetDev IP address, but it's really just reflecting what IP address is being allocated from the host side. And eventually you'll have to return a status of success, which will have to be pushed all the way back up to the CNI on the host side. So I just wanted to show like how much more updates there are on, through this kind of sequence if we let the CNI do IPAM on the host side. But that's just something that we need to be aware of. There's certainly a bit more simplicity in the original diagram we had, where the DPU kind of decides that information up front and relays it to the host within the context of the first CRD, rather than having to go back and forth a second time. Any comments?
I have a comment on this one. If there is any possibility of running a workload that would like to do its own DHCP, I think the sequence in which host or CNI is doing the IPAM would work. Is that accurate? Because then we are not going to have to proxy the IPAM to be done on the DPU to be then related back.
So is that like are you thinking in a multiple interface kind of situation?
Let me be very explicit. So let's say I'm using KubeVirt to deploy a VM instead of a pod, inside a pod, as opposed to just an application within a pod. And then that VM typically would always do its own DHCP. And so technically IP address allocation for that interface to which a given workload is associated with is pretty much in the control of the workload and not really DPU or even CNI in that sense.
But in that scenario, the IP still needs to be reflected back down to, let's take the DPU out of the picture. That would still need to be reflected back to the data plane, right? So that anything within Kubernetes that's, whether you're just general routing, so we could route to that IP, and any network policy around it. So the infrastructure still needs to know about that IP, correct?
Yes and no, in the sense that if I'm talking about virtualized workload, maybe maybe it's the MAC address. But let's go through the sequence of if we have to do routing and DPU needs to know about it, it can always sneak up on the DHCP requests and responses to know the IP itself. But I was curious actually. I don't know whether that is the primary use case. I'm just wondering if the host-based IP allocation is more suitable for those kind of use cases. That's where I was trying to get to.
Right. Well, my question was, really in the scenario where the DPU is not in the picture, does the infrastructure need to know about it? And if it does, then with the DPU and our networking is being done down on the DPU, he'll have to know about it as well. So if in that scenario, you don't think that the data plane needs to know about the IP address, then it's kind of a no op in that sense. But if it does, we'll have to, instead of right there where it says number 25, the CNI IPAM, that would just be your DHCP in the VM doing that, but we'd still need to reflect that back down. Correct? Yeah.
I mean, it's always good to know the IP address. For virtualized workloads, technically infrastructure, or rather the host layer or the DPU layer, need not know the IP address in order for it to work. If a VM is doing DHCP, then likely it is going to have interaction with the router natively. If that router happens to be in the DPU or on the host, then yes, it will get to know that IP anyways.
Right. So I would think that in that case, it's almost a no op, because I mean, if you're doing the DHCP in the VM in that case, we would need to do this handshaking.
Correct. The reason I brought up this case here is that is so we assume that there is no security implication whatsoever for having to have IPAM happening on the host or in workload. That's all I was trying to get to. So why don't we just assume that DPU may not be doing DHCP always?
Oh, why don't we reword that? So what you're saying, we don't want the DPU to do the IP allocation?
Well,
you're saying you want it to be in the CNI?
Yeah, I think that way, I think DPU wouldn't have to worry about if it is workload that needs an IP or if it is the host. let's explore more. Let's continue with this. I just wanted to drop this use
Yeah.
case that I'm running into as well.
Yeah, no, it's good. But I think the point that, at least in my mind, and I'm not sure, maybe Miriam shares the same, is for me, what's running down on the DPU is an extension of the CNI. So I
Mhm.
think the point that was brought up last week about like the subnets and you want, the CNI to do the IPAM. I mean, I would think I don't think it's, let's just call it OPI that's doing the IP allocation. It's whatever was doing it on the host has just now been lifted and moved down to the DPU. So it's the same block of code that would have been doing it before. It's just now running on the DPU as opposed to being run up in the, potentially. I mean, that's just a thought.
Yeah, I would be on the same page.
Yeah, that's not something that like OPI is taking on. It's really whatever was being done before. It's just being lifted and moved.
Correct. It's the extension of CNI that happens to either run on the host or a DPU. Yes,
Right. Correct.
correct.
And so we initially moved it to the DPU for simplicity of handshaking across, and we're trying to minimize, and it does, you said something about, I mean, for me, it is a bit of security. You're kind of, any decision points trying to move down to the DPU for security reasons around networking. So now it's really on the DPU, which is a trusted, environment to do the IP and allocation. And really the only thing that's decisions that are being made up on the host are which VF to use, because that's kind of inherent into what Kubelet's doing with the device plugin.
Right. I think my comment was exactly addressing that particular aspect, which is that IP address really doesn't belong to the infrastructure provider. It belongs to the tenant. So if I were to spin up a lightweight VM or some kind of virtualized workload in the pod, then the IP is something that belongs to a tenant. I mean, if I were to look at, like, for example, AWS cloud APIs and all that, IPAM is a job of a tenant, and of course, infrastructure knows about the IPs and all that, but strictly the boundary wise, it belongs to tenant.
Okay, that's a good point. It does add a bunch more handshaking, because I think the infrastructure does need to know about it. He may not be in control of it, but he does need to be aware of what it is for routing and policy purposes.
Right. Yeah.
And this flow represents exactly that, what you're showing, right?
The one that's on the screen, yes,
Yep.
This is the updated one. But like Miriam pointed out, it's another whole, a bunch of another set of handshaking involved.
Yeah, I mean, it's interesting to points that are brought up, and I think we can document them along with the diagram as well, around the IP allocation belonging to the tenant. And I mean, if we're happy enough, there's potentially not too much from an implementation view to jump from here, which was the original, option to just get the IP address, versus here, it could be just like a configuration thing in the CNI that does that. I'm not sure, but yeah, that's
Are you
really all
saying
I have
support
on
both depending on the configuration? You mean
yeah,
based off configuration, either the IP is allocated on the DPU or on the host, depending on the configuration setting?
yeah, for the CNI,
Okay.
yeah.
Yeah, it would have to be a CNI feature to offer this versus that. It won't be an OPI thing like we were discussing.
Right, but I think where OPI comes in is if we're defining what that NetDev CRD is, it may depend on if we knew for a fact that the DPU was doing the allocation, maybe the IP is in a different structure than, like, it's in the status field versus the spec field because of who's updating what is kind of where it came into play. Because in my mind, OPI would be defining what that NetDev CRD is.
Yeah. I think because OPI is defining the NetDev CRD because it happens to be the DPU representation of what is communicated back. So,
Right.
yeah. I mean, we can keep the OPI definition flexible to be including either one of the conditions.
Yeah. It's just good. That's only where it came into play. Is just how that data would be represented in the CRD.
Yeah. I mean, as such, CNIs have tons of knobs for variety of use cases. So it's okay to have a CNI expose this particular thing where they would want to either expose the IPAM allocation to be proxied in DPU versus not, and then offer this as one of the extensions.
Right. Okay.
I agree to keep it flexible. In case of the virtual machine, like a cloud operation, like AWS, user assign the CIDR block to the VPC, but IP assignment actually happened at infrastructure side. A user doesn't have to run the DHCP by themselves. So when the user initiate a virtual machine, the AWS basically assigned the IP address, and based on this CIDR block, user assigned to the VPC or subnet. And when user needs to manage the IP address, they typically use the elastic IP address, which user can carry the specific IP attached to the virtual machine. So I see that both ways. So the tenant may want to assign the IP address, but the tenant may rather don't want to deal with the IP address assignment by running the DHCP by themselves. So I think the flexibility is good.
Okay, cool. That sounds good. Seeing as we're talking about CNIs, so one of the things that myself and Billy and Donald have been talking about over the last couple of weeks is, potentially how this could work in heterogeneous environments. So that's environments where, you have a mix of hosts with no DPUs as well as hosts with DPUs. And let's say they're all part of a tenant cluster that's running Kubernetes. So at the moment, one of the things in Kubernetes is that you can't, pick a different CNI to work on the hosts with the DPU, let's say, versus the hosts without the DPU. So one of the things that we may want to look at and explore in a lot more detail is the idea of CNI delegation, whereby we can run this very simple CNI that does the VF plumbing on the hosts that do have a DPU, and then on the hosts that don't have the DPU, they're running their standard CNI like Oven Kubernetes, for example. But obviously, it's important that the DPU enabled hosts, the actually underlying infrastructure still conforms to the same constructs as the hosts CNI with no DPU. So essentially, Oven K is running in the DPU in the same way it's running up on the host side for non-DPU hosts. And then, on DPU enabled hosts, just the CNI on the host side is just a simple VF plumber, let's call it. And that's something that would be new. Would probably have to go to the networking SIG and be proposed and go through the motions around trying to get that through, if that's something that we see as being useful or beneficial. But it would certainly simplify the deployment models that are needed right now, which is you have to have the exact same CNI running everywhere. Have you guys thought about CNI delegation at all, or being able to mix and match CNIs in these heterogeneous environments, or has anybody kind of worked around that at all to date?
So, Mariam, the proposal here is that are we going to network sig to be able to extend because the CNI interface today allows us to have the pod allocation and deletion and the IPAM and all those things.
Yeah.
Are you suggesting that we have to modify that? Because I was thinking we can keep that exactly as is to how Kubernetes network sig defines.
Yeah. So
then,
I don't want to change the APIs for the CNI. What I'm talking about is more around the level of functioning where things like Multis work, where you have these super CNIs. But with Multis today, you're only allowed to do chaining of CNIs. So you can say, I want 2 CNIs to work on my Kubernetes cluster. And you cater for a primary interface and then the secondary one via your secondary chain CNI. But what we'd like to do is to actually be able to delegate. So you can say on, for certain pods, I'd like this type of CNI to run, or this type of CNI to run, rather than this and that. So I do think that there will be some work to do at the SIG network level. Right now, they're doing some work on enabling multiple networks for pods anyways. And this could be like a further extension of that work, which is not just multiple networks, but kind of figuring out interworking of different CNIs together, but through the super CNI kind of interface.
I see. Okay.
I have one question in that proposal. Are we tend to actually handle all the servers that we have in a cluster, where some of those they have XPUs on them, some of those they don't, and they are just typical servers? Are we going to handle them as the same in the cluster? Because then you need this CNI delegation, as you say, but what if we just handle only the servers where we have XPUs as a specific pool of servers where you can actually run specific pods and you can use only one type of CNI, and all the other servers where they don't have XPUs as another pool with specific characteristics? Does that make sense? Or
It does, but I don't think deploying the initial setup with your CNI allows you to do that. I mean, you can say, with labels and taints that I want, you can kind of say this workload I only want to run if you have a DPU, a node with a label of DPU. But I don't think at the CNI level you can say, I want CNI X when a node has this label, and I want CNI Y when a node doesn't. And I think that's what we're talking about. I think labels and taints will allow you to do what you're talking about as far as workload distribution.
I mean, let's take as example the OVSNI, okay? The OVSNI has a marker component that actually exposes the OVS bridge as resource to the node. So when you have like a network attachment definition that actually says OVSNI in it, the pod will actually get spinned up in a node where you have an OVS bridge, because this OVS bridge is a resource of the node. So there is no label and taints and stuff like that. You have a resource of OVS bridge in the node, so your pod gets scheduled directly in the node with the OVS bridge. So what if we expose the XPU as a resource to the node, and then the CNI knows which node to pick in order to spin up the pod?
I will have to look into resources. That sounds interesting. I'm still not sure at the CNI level, if you can do that. And that would be not, maybe there is a way, I don't know. I mean, kind of today, you know, for some of the stuff that's working in OpenShift, I mean, we have the same CNI OVN Kubernetes running everywhere. And then if you're on something that has a DPU, it kind of has a flag that says that. And so it kind of goes in a shim mode. It's the same code. It's just like there's an if statement. If I have a DPU, go do this, else do everything you normally did. So it's the same code base. It's just a, you know, an if statement that branches into a different code path. So I think what we're talking about is allowing a different CNI to run potentially.
Okay. Yeah.
Maybe the resource thing comes into play only if you are limited on number of resources, and there are ways to handle that. And
Well, if you have limited resources, that's where the device plugin comes in. Where you,
correct.
Yeah.
Correct, exactly. So I was just alluding that, you know, if you can handle the resource limits in that way, then you don't need something whereby you need to know where can I allocate VFs versus not. And therefore, if you have VFs or if you have DPUs underneath, then you can use it. Otherwise, continue with that. Now, if you need certain workloads to be high performance workloads and you need them to be deployed on certain nodes that have specific DPU capabilities, that can be handled through a variety of mechanisms as well. So I'm still not sure, why do you need anything specific in definition?
Yeah, I guess we're talking about the difference between the scheduling of workloads based on resource pools versus the CNI that actually runs on those hosts. And in the case where, so today, in the case where we have a DPU on a host, the coupling is actually very close between the CNI that runs on the host and the DPU, in that it is just reflected down onto the DPU side. But if we want to do something that decouples the two clusters a little bit further, in that, you know, we want to be able to deploy workloads on the infrastructure side, then we would like for the CNI on the host side of the DPU to be rather simple, which is plumb a VF to a pod, and it can be either a primary interface or a secondary interface. It doesn't really matter, but that's all I want that CNI to do. I don't want it to have to continuously communicate via gRPC or some other mechanisms down to the DPU to do things.
I agree with that, but adding a simplistic CNI to an existing CNI should be easier, in the sense that if the host-based code is simple enough that all you need is a small if statement to bypass all the big stuff that you would have done otherwise, should be easier than to incorporate in any existing CNI and call it a unified CNI rather than having to have two different CNIs. That's where I was trying to think. Why?
Yeah, I guess it's just a difference of having to touch every existing CNI versus produce one simple CNI that does it. You know, it's I guess it comes down to a decision around that. Do we think that every CNI today will modify their existing code path to be able to cater for the simplistic case that we spoke about? Or is it worth having something simple today that can be just downloaded and used?
So let me, sorry if I missed any of the recent meetings where this was debated, but
it wasn't. This is just kind of stuff we've been brainstorming on. You didn't say that.
Okay. So in that case, you know, we are talking about modifying brownfield CNIs and not really creating a new CNI. Is that the case still? Or are we saying we'll just create a simplistic CNI that will work for DPU-based deployment independent of existing CNIs?
I think that's what this discussion is. We've always talked about modifying existing. And so we are just raising, is it worth considering doing the latter?
Okay.
And so we kind of, now in the past, I mean, you know, I think in my mind, I had that simple, if it's a DPU, go down and do this lightweight set of code, else go do what you normally do. And I think Boris grabbed that and was calling it a shim. And I was like trying to get away from just having a shim CNI and more maybe if OPI wanted to do more of a library that could all do the same, you know, like plug a VF into, and that's all it does, into the pod, and that's all it does, then maybe that could be, you know, a library within OPI, and then all the brownfields could say, if DPU, call this library, else go do what you normally did. And in my mind, that whatever that was the shim, but now we're saying, well, do we want a shim or do we want more of that route where it's the same CNI that if DPU go do this minimal set of code, else go do what you normally do.
Right. I guess now I understand the comment Miriam was making, that, you know, in that case, you have to use either or CNI on certain nodes versus a unified CNI that does both.
Yes.
And there's a use case as well, right? If we break it down into simpler one, like how Miriam explained, then it's a common deployment solution that all DPU vendors can have, and it's open source repo wherever it is to be downloaded from a common minimalistic host-based functionality put together in a library form.
Yeah, I'm all in for a different CNI. The main thing was that, you know, we weren't sure if we will be able to bring in various other features of other CNIs that users are using for whatever reasons they like those CNIs. Otherwise, creating a CNI for DPU is the simplistic, easiest way to start rolling Kubernetes with
Right.
DPU.
But from what we were, at least Mary and I were thinking, is that whatever those features were that CNIX provided, those are still being provided, but they're running on the DPU as opposed to on the host. So this is purely a shim for plumbing into a pod, and all that existing functionality is still being done, but it's done on the DPU.
Yeah, unless you split the interfaces like we do in Multus. I don't know how if you can do that, wherein for an interface, there cannot be two CNIs technically. There should be only one CNI per interface. So
That is correct.
if we go that route, then we are back to the Multus model, wherein a VF is only used by this CNI we are talking about for DPUs, and for the rest there is the standard interface that, you know, that plumbs the pod into the rest of the Kubernetes network. And so the catch is that, you know, if you have two CNIs, then the security posture that, or the firewall or whatever use cases we have, that doesn't go well with it, because you still have one leg sitting in a path that is not going through DPU. And then the question of whether if all traffic is not going through DPU, then am I really getting the security I was expecting out of it? So, well, I think the comment really here comes down to is we cannot have some features implemented by traditional CNIs and the rest by using this one, because ultimately we'll have to see how existing CNIs could use DPUs, or a CNI that can expose DPU features can be leveraged by the applications.
Billy, question. Last week we discussed the device plugin SROV, and Nupur said that they're adding SIOV to the SROV, right?
Mm-hmm.
Yeah, so Boris, that's what we were like, how Miriam explained, right? That was the approach we're trying to take, right? From security model, you cannot have primary some different CNI and secondary some different CNI.
Correct.
Because we wanted to unify it together so that the security and the connectivity, pod connectivity eventually is handled completely by DPU in a secure environment.
Correct.
From that approach perspective, if I look into it, then yes, DPU CNI is different from rest others from functionality perspective, because DPU CNI will do bare minimum things on host. Rest everything is controlled by DPU infrastructure or CNI, right? Whatever is running on infrastructure.
Correct.
And from the same perspective, we came across like the discussion this panel is going through. We also brainstormed on the same thing. Now the question is, should we have a device plugin on the host that understands all the interfaces that DPU supports today and be a common generic plugin that makes everything available based on configuration. And that's the approach we took in creating this generic plugin, device plugin, which will support all kind of interfaces that a DPU can provide.
And all CNIs can use this device plugin?
As long as, yes, the pod requests for that kind of resources, yes, that device plugin is there. It will support based on configuration. It will support, today we are supporting SRIV and subfunctions together in one. So it can be enhanced for other kind of interfaces as well for supported by TPU.
No, let me ask you a question. What Boris is asking differently. So say that yes, using device plugin method, you can allocate a device using an existing CNI can allocate a device and all that. But then to implement the functionality of what goes into the DPU, wouldn't the CNI have to change or do things differently in order to leverage that to come from DPU and not from the host kernel or some kind of host stack?
I agree, Vipin. This is the little open in terms of what we are discussing here, right? Should we consider DPU a special case and have a DPU based CNI which behaves differently compared to the others, right? The other CNIs. If we keep a generic device plugin, then all other generic CNIs, when they're requesting for a special resource from this node, need to understand that this particular, whatever we created, device plugin behaves differently, right? So we have an open here, and in terms of a DPU-based CNI versus a generic CNI working with working on a DPU, what approach do we want to take?
From my perspective, if we have like a new CNI that is specific, tailor-made for DPUs, you have two parts in there. The virtual functions that actually get exposed and they belong to the DPUs are typical virtual functions like NetDev devices. So the CNI will actually plumb those virtual functions inside the pods. So that is the host part. And then the second part
Can we
of
pause
the CNI,
there for a second? So when that plugs in to, I mean, the CNI may have to be updated depending, because not all CNIs may support VFs being plugged in. They may like be hard coded to only use like V pairs or something. I mean, they can, the code is out there. I mean, to plumb in a VF, but not all CNIs may be able to know like where to find the NetDev for a VF and how to plug it, how to plumb it into a pod. So there may be work there in the CNI if it doesn't already support VFs or subfunctions, right?
yeah, but if we create a new CNI for DPUs, we don't reuse the old ones, then we can just implement the functionality that we need, like plugging VFs.
Right.
Right.
Right. That was kind of what like Mayor and I were talking about, is that whatever is running on the host is tailored to plugging like VFs or subfunctions into the pod.
Yeah.
Right. And that's exactly my point, right? Because primary interface, as we are talking about, many of the CNIs today do not support any of the DPU interfaces for it.
Mm-hmm.
Yeah. I mean, doing a DPU based CNI is probably can be consistent across DPU vendors and can be easier to get out. The main question we are struggling with is, are users going to take that versus what CNIs they have in place? It will be easier. We can define the CRDs we are talking about here quite easily for DPUs. And also, I believe the second point you were going to bring up, Dimitros, was that first part is the host. The second is actually implementing all that functions, if I'm not mistaken. And all
Yeah,
that.
the second.
Yeah, go ahead, please. Yeah.
The second part of the CNI is to actually communicate with the API that is exposed, like the
Correct.
generic API that
Correct.
all the vendors adheres to, right?
Exactly. Yeah.
And then create the configuration that you need
Exactly.
in your XPU,
Yeah.
so you can allow traffic flow in
Correct.
to that VF that you have plumbed in inside the pod.
Exactly. I think that's what I thought you would bring up as the second point. So it's the VF plumbing part, which is the first part, and second is actual configuration of the DPU, because that configuration is what most of the CNIs are implementing in host stack. Either it is the Linux kernel on the host, or it is some kind of XDP functions or UPF functions or equivalent, right?
Yes.
But that is, if that is exposed consistently through DPUs in some way, then sure. I mean, the CNI that does DPU specific is all good. But
Miriam, can you maybe flash the slide? Because I think the DPU host agent that you presented, this is what's responsible to actually communicating with the DPU, right?
Yeah, so at the moment in this diagram, it is, and there's a update on that in later diagrams. But what I wanted to call out was, like, I just want to make it clear that in this model where we're talking about running a simple CNI on the host side, we still expect the existing CNIs functionality, like OvenK or whatever, to be described down to the DPU, and that to be configured on the DPU and still function in the same way as it originally did on the host side. So all we're trying to do is essentially simplify the host side with a simple CNI, but still accomplish the same old full networking infrastructure offload for the tenant on the DPU, if that makes sense. So almost like you have, I guess it's really important to remember here that we have this, when we're talking about these different CNIs and all of this mixing and matching, is that we're talking about a clean separation as well between the tenant cluster and the infrastructure cluster. So I still want my OvenK type behavior running on the DPU, and that will be the real, networking offload from the tenant side happening on the DPU. All we're talking about here is having a simple CNI on this side that plumbs VF to pod. And the reason why we want to be able to delegate CNI on the host side is that in my normal hosts, or my non-DPU enabled hosts, they're going to be running OvenK anyway, so they need to play nice with the DPU today.
Yeah. So Miriam, in your diagram, you're saying that instead of running the CNI that was running on the host, you run it on the ARM of the DPU and be able to achieve pretty much everything that the CNI was offering, except for this tiny host CNI, which is helping you plumb the VFs down south into
exactly.
the DPU. I think that will work. That will work. The only, I would say, concern I have with this approach really is that if instead of using the host kernel on x86, you are definitely offloading it to the ARM on this, and possibly leveraging any offloads that could be programmed for kernel, for anything that exists in Linux kernel offloads, maybe flow offloads and things like that over there. But the ultimately benefit is going to be only available if the real data path can be fully realized in the DPU's data path and not an ARM complex, because otherwise it will be exchanging the x86 cycles with the ARM cycles. But then is that the biggest offload that you would get? I would probably think not. The biggest gain will come from the fact that as VF traffic gets dropped into the DPU data path, the processing of all the functions that CNI offers happens in the DPU's data path, because Otherwise, you will have a context switch happening between the DPU's data path into the kernel, back into the DPU, and on and on.
Yeah, sure, I agree with you. Like the oven K on the DPU side will need to be modified to make sure that it can reflect everything that it wants
Right.
from an acceleration point of view on the DPU. I'm not disagreeing with that.
Correct.
And you know, there's going to be certainly programming and development done to make that work. And hopefully it uses an OPI API to do that description at a high enough level that things can get translated to both the kernel on the ARM cores as well as the accelerator itself. And the idea being that you have a control path or a slow path for things that can't that the accelerator doesn't recognize or doesn't understand how to process, you know?
Yeah, I think.
Yeah, I agree with that. There's going to be some exception packets that you still need to punt up. But otherwise, most of the things, performance benefits are from optimization that happen in the accelerator down there, all entire flows.
Yeah.
But that just
And
hiding the problem that we had beforehand. Now we say all the CNI is running inside the DPUs, and all of them, again, still need to change in order to accommodate for different acceleration engines, whether it's P4 pipeline or something else. We didn't resolve kind of anything, right? We just pushed the problem inside the DPU, right? Yes, on the host, maybe we can run simplified CNI, but the problem remains what's going on inside the DPU.
Yes, in a way, Boris. At the same time, if the mechanisms, I want to extend that comment further. If the mechanisms used to offload what exists on DPU to be exactly similar to how you're offloading Linux kernel, that also will not cut it, in my opinion, because you could do that with flow offloaded NICs today. You don't need a DPU for that acceleration. Now you will get the tenant separation. I'm agreeing with that use case of security aspect of it, but let's also understand how many users are buying not CPUs, buying DPUs for acceleration benefits versus how many are buying it for the separation of tenant versus the infra provider.
And which way do you think it's leaning?
I would say we can get both. If we were,
Yeah, I mean, the goal is to get both. I didn't quite catch if you were trying to say that they're buying them for one or the other, or was
well, my take is that mostly people are wanting to get better acceleration and better throughput and lower latency. That is the immediate use case. Not many people are going to be wanting to have that separation as the primary use case. Now, this is where I mean, users need to step in and say what use case appeals to them more. But if we target it exclusively for the use case of trying to have the workload and infrastructure separation, that's okay. All I'm saying is let's validate that it is the primary use case.
Right. I mean, I'm aiming for both. I mean, I think they both play a part, and so you know, I think the security is important and the acceleration. So the point though is that, you know, once you get it down there, Boris is correct. You still have to, you know, you get that CNI, you still have to update the CNI for that. However, correct. I mean, you get the security once you've moved it down, and then you know, you can change if now they want to accelerate, then they can change the CNI to, you know, with additional changes by calling these APIs, the OPI APIs, to set up the data plane.
Correct.
But I was still kind of in the back of my head of things like Cilium, where, you know, we may not be able to accelerate it completely because it's doing so much eBPF, and maybe, you know, what the Cilium's value add is more observability into in network policy and less, you know, the acceleration. And so, you know, you moving it down, you have the security, and you at least have it running down there, and then there may be spots that you can accelerate over time.
Yeah. Things that cannot leverage DPU, that's there, because we can make it leverage DPU in one way or the other. But the ones, the users who would want to, and if we can, then those are the ones we should be interested in.
I'm really sorry, folks. I have a hard stop here. For a future topic, we do have a few slides on potentially how we can get rid of the host agent and maybe leverage the device plugin on the host side as the entity that is managing the DPU CRDs. If there's very few CRDs that are new, you know, it probably makes sense to leverage an existing daemon set on the host rather than trying to create a brand new one just to manage two types of CRDs, assuming that the infrastructure is monitoring all the existing resources and the tenant cluster anyway. But again, like we can dive into that in much more detail at another time. I'm really sorry.
No, thanks a lot, Miriam. That was very good.
Yeah, I appreciate the details, Miriam. Thanks, and Billy.
Okay. Anything else to cover today, or we can go ahead and give everybody at least a few minutes back on the day, and we'll pick up again next week. All right, everyone, enjoy the holiday weekend, and we'll meet again next week.
Thanks.
Yeah,
Thanks.
same. Thank you.